Okay, now we're going to look at arithmetic sequences and series. An arithmetic sequence is a sequence of numbers in which every two terms are separated by the same amount. In other words, they have a common difference. For example, the numbers 2, 6, 10, and 14 are all a difference of 4. In other words, by adding 4 to the preceding term, you get to the next one. So 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14. So they have a common difference. As a recursive formula, you could write this as an equals the n minus 1 term plus d, d standing for difference. And so rewriting this in terms of its recursive form, 6 again is 2 plus 4, 10 is 6 plus 4, 14 is 10 plus 4, and so forth. This sequence can also be seen as A1 equals 2, which is 2 plus 0 times 4. A2 is 6, which is 2 times 1 times 4. A3 is 10, which is 2 plus 2 times 4, and so forth. In other words, they're all multiples of 4 plus 2, and so we could write it in that form. Again, A1 is 2. This should be written down, by the way. The general form of this sequence can be written in this form, and this will be a very important equation for us to use whenever we're dealing with arithmetic sequences and series. The really important thing is this D. That's what clues you in that this is an arithmetic sequence. They have a common difference. This type of sequence allows a shortcut compared to other sequences because the nth term can be determined without finding any of the preceding terms first. For example, in the sequence 3, 10, 17, and 24, note that all of them are different by 7. 3 plus 7, 10 plus 7, 17 plus 7. The general form can be written this way. An equals 3, that's the first term, plus n minus 1 times 7. So 10, the second term, would be 3 plus 1 times 7. The third term, 3 plus 2 times 7. Notice this one's always going to be one less than the term. So if I want the 49th term, note the 48 here, one less than the 49. It's 3 plus 48 times 7, which is a total of 339. In the sequence 2, 6, 10, 14, the result of adding the first two terms is 8. The result of adding the first three terms is 18. The result of adding the first four terms is 32, and so forth. Now this creates a new sequence, 2, 8, 18, 32. In other words, the sum of all of those. And this sequence, Sn, for the sums, can be written in this form. If we substitute in A1 for the 2 and D for the 4s, then what you'll notice is this becomes Sn equals A1 plus A1 and D, A1 and 2D, A1 and 3D, and so forth. Or in general, A1 plus n minus 1 times D for the nth term. Since the difference is always D, we could start with An and work backwards. Note here, Sn equals An, and then An minus D, An minus 2D, and so forth. And if we put the two together, in other words, this first way, in which we started with the first term and added 4s, and then the second way in which we started with the last term, the nth term, and subtracted the d's, subtracted the 4s. If we put those two things together, we have a little bit of canceling out, and we get a general form for finding the sum of all of the terms in an arithmetic sequence. And basically, it's just the average of the first term and the last term times n over 2. In other words, the average of the first and last terms, these two divided by 2, times however many terms are in the sequence that we're looking at. So, if we were to look at 2, 6, 10, 14, the sum of three terms would be since we're doing 3 of them, 3 over 2. And then the first one was 2, the third one was 10. So 2 plus 10, that's 12. 12 divided by 2 is 6. 6 times 3, there's our 18. The sum of the first 4 terms would have been, again, 4 here to match the 4 there. The first term was 2. The fourth term was 14. So 2 plus 14, that's 16. Half is 16, 8. And so we get to 32 for our total. So basically, if I'm given the first term and I use the first equation I had to find the nth term, then I can just add those two times n over 2 and I can get the sum of those terms. So because of these two formulas, I can solve different problems for arithmetic sequences much more easily than I could for a general sequence. So let's look at some examples. For the sequence 3, 10, 17, 24, that was the second one that I had you up here. Find the sum of the 20 terms. Well, first I need the 20th term, but using the first formula, that would, see 20 here, 19 there, so it's 19 times 7. They all had a difference of 7. So 19 times 7 plus 3 gives me 136. And then now that I have the 136 for the nth term, I have the first term, 3. So 3 plus 136, that's 139. 20 over 2, that's 10. 10 times the 139 gives me a sum of 1,390. So very quick to find the sum of the first 20 terms. Alright, so we've been given that A1 is 5 and D is 10. Find AN and A100. So AN is just the general form for A1 is 5 and D is 10. And then we're going to use that to find A100. So first off, AN is A1 plus n minus 1 times D. That's always the general form for an arithmetic sequence or series. And here I'm just going to plug in the A1 and the D. And so I'm going to get, so AN equals 5 plus n minus 1 times 10. Now, I could leave it that way, or I could simplify it. And so this would become AN is 5 plus, and then this would be 10n minus 10. And that would lead to then AN equals 10n minus 5. And so there is my general form. This is the answer that you would likely find in the book if you were checking your work. I kind of like it in this form just because it's easy to do in terms of keeping straight that arithmetic sequence formula. Now that I have that, I want to find A100. So A100. Now if I use the top one, that would be 5 plus 100 minus 1 times 10. So that's going to be 5 plus 99 times 10, which is 995. If I wanted to use this form, I would have had A100 equals 10 times 100, subtract 5, which is 1,000, subtract 5, which is, again, 995. So either way gets me to my answer of 995. So one way to use the formulas to find out the particular term, knowing the difference and knowing the first term. And again, this 995 is the 100th term of this particular sequence. Now, let us suppose that I've been told the 5th term is 23 and the 10th term is 48, and I want to find the 40th term, but that means I'll also need to know the first term and D, because again, using that general form, I need to know those two things to find out the 40th term. Now when you have something like this, I can use this equation for each one of those. So for example, the 10th term, well, I know that's going to be A1, it's always A1, plus, since it's the 10th term, that has to be 9D. And so that 10th term, that has to be 48. Now, the 5th one, well, that's going to be A1 plus 4D, and that has to equal 23. Note, all I've done is taken the general form that I had right there and rewritten each one. They both have the A1, and then that number has to be one less than the subscript number. Now, this gives me two unknowns, A1 and D, and two equations. So I can solve, and it turns out that when I solve these things, I'm almost always going to solve them using elimination method, because since they both have A1, I know that if I just subtract, then I get rid of my A1s and I have just the D's. So 9D minus 4D, well, that's going to give me 5D. And the 48 subtract the 23, well, that's going to give me 25. And again, all I did was take the top one and subtract the bottom one. The A1s are gone, and I have 9 minus 4, that's 5D. 48 subtract 23, that's 25, and now I have my D. My D is 5. Now that I have the D, I can go back into either one of these to find the A1. I usually take the smaller one, just because, again, smaller numbers make it easier. So A5, okay, so A1 is going to equal, well, that's got to be 4, A1 plus, use the formula, A1 plus 4 times 5 has to equal 23. So A1 plus 20 equals 23, so A1 has to be 3. Now that I have the first term and I have D, I can rewrite my general formula. In other words, AN has to be, well, A1 was 3 plus n minus 1 times 5, where I've plugged in the A1 and the D. And so A40 is going to be 3 plus 40 minus 1, that's going to be 39, again 1 less than that, times 5, and that gives me an answer of 198. So this is what A40 is, 198. And here was my A1. And my D. The key again being I had two equations and two unknowns. I used them to find out the D and the A1, and now that I have those plugged into my general form, again I'm always coming back to that. Now that I have my general form, I can go ahead and find the 40th term. Alright, now we're going to do a similar kind of problem, except I'm not only going to find, in this case, the 50th term, I'm also going to find the sum of the first 50 terms. So that's what that represents. This is the 50th term. This is the sum of the first 50 terms. So similar to what I did before, I have A8, and A8 is going to be A1 plus, since it's 8, 70, and that has to equal 51. And then A3, well, that's A1 plus 2D, and that is 16. Just like before, I'm going to subtract and get rid of my A1s. And so that's going to leave me with, again, 7D minus 2D is 5D. 51 minus the 16 is 35. And so in this case, D is 7. So again, my A8, A1 plus 70, my A3, A1 plus 2D, A8 was 51, A3 was 16. Subtract to eliminate the A1s, gives me 5D is 35. Divide both sides by the 5, D is 7. Now that I have that, I'm going to come back in and find out what the A1 is. So I'm going to use the second equation for that. So A1 plus 2 times 7 equals 16. Well, 2 times 7 is going to give me 14. A1 plus 14 equals 16. So that's going to give me A1 is 2. Now I've gone ahead and underlined them, but please note the problem did not actually ask me to find D and A1 as it did in problem 2. You're going to always need to find these in order to be able to find things like A to the 50, A50, and S50. So no matter what, when you do this process, you're going to have to come back and find D and A1. And I'm almost always sure that you're going to find D first and then the A1 afterward. Now that I have that, I can go ahead and find A50. So A50, well, that's going to be, let's see, A1 plus 49 times D, which A1 we've already found to be 2, and then we have 49 times 7, and it turns out that that is 343 plus 2, 345. Now, the S50, well, that's 50 over 2. Those have to match. And then it's A1 plus A50. So basically, that's going to be 25 times, well, A1 was 2, A50 was 345, so that's 347 times the 25, S50 is going to be 8675. And so we have found the sum of the first 50 terms given just the third term and the 8th term. Again, note the process. I wrote out the 8th term using that same formula all the time. Wrote out the third term, 2 equations, 2 unknowns, eliminated the A1s to find D, plug that back in to find A1. Used A1 now to go find the 50th term, in which this has to be 1 less than that, so 49 times D, which was 7, And then once I have A50, I can now go find S50. All right, let's use a clean sheet here to do the next one. Here we're going to go backwards. We have S24, so the sum of the first 24 terms is 60. We also have A1 is 4. We want to find D. We want to find out what the 116th term is. So, have to go in a little bit different direction here. So, first off, S24 has to be 24 over 2 times A1 plus A24. So all I've done is taken the general form that I had right up here. So that's what S24 is, even though I don't necessarily know what A1 and A24 are yet. That has to be true. What I know is that basically that's 60. S24 is 60. 24 over 2, well, that's going to be 12. And then A1, I've already been told, is 4. I can now find A24. Well, A24, all I have to do is divide both sides here by 12. And I'm going to have 5 equals 4 plus A sub 24 there. And so that's going to tell me then that the 24th term is 1. Now, I can then turn around, now that I have that, and go, all right, well, A24 has to equal A21 plus 23 times D. Again, this one is one less than that one. I know what A1 is, so basically A24, that was 1, A1 was 4, plus 23D, solving for D, I end up with, well, 1 minus 4, that's negative 3, so D is negative 3 over 23. So please note, the D does not have to be a whole number. It can be a fraction. It can be negative. Now that I have that, I can go find the 116th term. So 116 is going to equal A1 plus 115D. Well, A1 is 4. 115 times, we just had the D of 3 over 23. It turns out that 115 is divisible by 23. It turns out to be 5. So A116 is going to equal 4 plus, that's negative, so a negative 15. A116 equals negative 11. So, started with the sum, worked our way back to the nth term, and then we could go find a different final term. Okay, in this last one, we're given a sequence of numbers. We want to have the sum of the first 50 terms. And they don't explicitly tell us anything. However, when I look at this, this is A1. Okay, so, and I notice that everything is a difference of 3. 8 plus 3, 11 plus 3, 14 plus 3 gives us the next term. So, we have A1 is 8, and D is 3. So, A50 Well, that's going to be 8 plus 49 times 3, which is 155. S 50, again, we want the sum of the first 50. Well, that's going to be 50 over 2. The first term was 8. The 50th term was 155. And so the sum of the first 50 ends up being 4075. And there you go, the sum of the first 50. You might want to pay attention to this particular one because it's a typical kind of problem that you might find on a standardized test or on one of my quizzes or tests, where you have to look at your sequence of numbers, decide your A1, your D, use your two formulas. Okay, again, this one was using AN equals A1 plus N minus 1 D. And then this one was SN equals N over 2 A1 plus AN. So using those two formulas, we can, depending on the problem and what information they tell us, solve for various things that we did not know. And so there is section